So we've been computing probabilities in class, and if you remember, the probability of a success is the number of successful outcomes. So you count the successful outcomes, and that's divided by the successes plus the failures, which we call the total outcomes, right? So successful outcomes divided by total outcomes. The thing is, we've run into some more complicated problems that require more sophisticated counting than just, adding stuff up on our fingers. And so that's what I want to take a look at in this video is 3 examples where we have to use our counting tools, specifically combinations, to compute these probabilities. But the goal is the same. We want to make a fraction with successful outcomes divided by total outcomes. So let's attack this first problem here. A class has 5 boys, and I'm just going to highlight some things as we go. 5 boys and 7 girls. So right away, I like to make a note that there are 12 total students. 12 students. And I don't know if you can read that or not, but that says 12 students. That's just a little note for me. If the teacher randomly picks 5 students, so we are going to choose 5 from our 12, 5 students, what is the probability that she will pick exactly 3 girls? Okay. So even though they just mentioned that we're picking exactly 3 girls, because in this particular class that's described here, we only have boys and girls, selecting 3 girls means that we're also going to select 2 boys because we're selecting 5 students total. So the counting becomes more complicated because we're only taking 3 of the 7 girls we have available. So basically what we need to do is we need to find out how many ways can we get 3 girls. So we have to count those ways. How many ways can we get 2 boys? I spelled boys wrong. Whoa, way wrong. It's been a long day, apparently. How many ways can we get 2 boys? And then what are our total possible outcomes? Okay. So to figure out how to get 3 girls when you have 5, we have 7. We have 7 girls and we want to choose 3 of them. We use a combination. And so we're going to do 7C3 to decide how many girls we get. And when you plug that in on your calculator or use the formula, you're going to get 35. There are 35 outcomes where we choose 3 girls. We have to do the same thing for the 2 boys. We have 5 boys to choose from, but we only want to choose 2 because we have 5 students total, right? We're picking 5 students. When you do 5C2, that ends up being 10. And then in terms of our total outcomes, we have, 12 students? Remember when I wrote that down here? And we are choosing 5. So 12C5, that's going to be 792. Okay. Now, to count up our successful outcomes, we have 35 ways to choose the girls and 10 ways to choose the boys. We're going to multiply those together. So our calculation for this problem is 35, because it's the 7C3, times 10, that's the 5C2, and then we divide by the 792. And when you compute this on your calculator, it works out to be approximately 0.4419, and that is choice A over here on the multiple choice, 44.192%. And the key here was to count these things separately. How many ways can we choose 3 girls? That's a 7C3. How many ways can we choose 5? How many ways can we choose 2 boys? That is a 5C2. And our total outcomes is 12C5 because we have 12 people and we're only picking 5. When you are counting multiple situations, right, multiple events, you multiply those together. So choosing the girls is 7C3. Multiply that by choosing the boys, which is 5C2. Those are your successful outcomes. Okay, so let's try this again on a new problem now that you've seen it in action. So here's that last one. A shipment of 10 smartphones contains 4 with cracked screens. So I have 10 phones, 4 are cracked. That means 6 are not cracked. If sold in random order, what is the probability that exactly 2 of the first 5 sold have cracked screens? Okay, so first of all, let's compute our total number of outcomes. We have 10 smartphones, but we're only selling 5. So that's a 10C5. Now, I want to make sure I have 2 of these 5 are cracked. And since there are 4 to choose from, that's a 4C2 for the cracked. And we have 3 more that aren't cracked that we have to pick. That's a 6C3, right? Because there are 6 that aren't cracked. And I only need 3 of them to get my total of 5. And then the numbers on this are 6 for 4C2 times 20 for 6C3, and then we'll divide that by 252. And that comes out to be approximately 0.476. That's 47.6%. Ooh, that looks like letter C. Okay. So what we're trying to do is get you in the habit of counting the categories separately and then multiplying those together. We just use the counting principle to do that. So these are the cracked. These are the okay ones, not cracked, right? And then our total down here, our total number of outcomes. And we use combinations to count all these things. So this takes practice, and we're going to slow it down a bit. I know some of those problems that you were assigned the other day were a little more challenging, but seeing these 3 in action and practicing those 8 problems that we did in class should help get you moving in the right direction and clarify several of the problems that you had trouble with last night. If you have questions, you know where to find me, of course, and in the meantime, take care.